Yes, welcome to the next session of rehabilitation and retrofitting of structures course. In the last session, we were discussing regarding the various techniques or semi-destructive techniques we were discussing. In that we have been discussed the penetration techniques and pull-out and pull-off test. So these two techniques we have been discussed, and we also been learned how exactly we are going to conduct these tests in order to assess the performance, that is quality and the strength of a concrete. Let us move on to the next, that is core sampling and testing. So this is a very important test. Why? Because this particular test is majorly used test as per Indian code, and this is the majorly performed or conducted semi-destructive technique in order to assess the strength, quality, everything. Is it clear? So let us get into this core test, or I can say the core capping test. So this concrete core are used for testing of actual properties. The principle behind this test is they are going to use a specific equipment to take a concrete core or a core from a concrete specimen, that is reinforced concrete specimen, okay, with reinforcement, sometimes without reinforcement, and whatever the concrete core you are going to take out from the original concrete or a concrete member. So from that core we are going to assess the strength, we are going to assess the durability properties, like we can perform a permeability, we can perform the carbonation, we can perform the chemical analysis. So that means I can say the advantage is more in this particular technique. By taking out a concrete core, we can conduct the strength, we can conduct the durability. Okay, so this performance we can assess by these concrete core members. So hence I can say this technique will be more predominantly used in Indian condition also. Okay. So coming to the first thing, let me go step by step. Okay, I will start with how exactly the core will be taken out, and then I will explain, okay, how exactly we are going to do the preliminary test, that is called capping, and then how to test it, and also I am going to showcase one small result, or how to interpret the result. So all those things I am going to explain step by step. Is it clear? So let us see first one, core sampling and testing. That means how to sample that and how to test that particular specimen. Okay. So coming to the sampling, okay, concrete core are usually cut, or I can say taken out by means of rotary cutting tool with diamond bits. So this is the equipment they are going to use in order to take out a concrete core from a reinforced concrete member, that is rotary cutting tool with diamond bit. Okay, whatever the core they are going to take, it will be in the cylindrical shape. So that's what, in this manner a cylindrical specimen is obtained. Okay, a cylindrical portion, okay, it will be having a certain diameter with a sufficient height. And whatever the specimen you have been taken, or cylindrical specimen you have been taken from that particular reinforced concrete member, those edges will be, the edges will be on either end will be uneven, it may be roughened, okay, or it may be flattened. Okay, many circumstances you may come across when you are going to take out that concrete core from the reinforced concrete member. Is it clear? So that's what, uneven, parallel and square, and sometimes it's embedded piece of reinforcement. So the reinforcement also will be there when you're going to take out the core from a concrete member. Next, the cores are visually described and photographed, giving specific attention to compaction, distribution of aggregates, presence of steel. That means whatever the core you are going to take out from the concrete member, whatever the core you are going to take out from a concrete member, so not only you can perform a strength test and durability test, also visually you can see that what is the depth of that particular core, or I can say we can correlate with what is the depth of the concrete we have been provided in that particular member. That is one thing. And also we can see the distribution of aggregates. So all those things, and also the compaction. So all these things we can see in when you're going to take out a core from a concrete member. So it has got a more advantages. Okay, strength, we can assess the strength, we can assess the quality, we can assess the durability. So many things we can perform by taking out a concrete core. Is it okay? Is it clear? Next. So whatever the core they are going to take, so this is the thing you need to done. So that means you need to soak it, okay, then you need to cap it. Okay, I will tell you why you require a capping. Okay, and you are going to do the capping with molten sulfur or sometime with a cement paste also. Okay, with the right angle to the member and then test it. So this is the procedure you are going to do. So after taking out the core from a RC member, you are going to soak it in water, you are going to cap the specimen, you are going to cap it with the sulfur, or you can cap it with the cement paste, and then you are going to test that particular member. So this is the step-by-step procedure you are going to do. So let us explain all those things. I will going to explain the future slide. Okay, how many times or how many days or how many hours you need to soak it, and how to do the capping, okay, and how to test it. All those things I am going to showcase you in the next slides. So you can see here, this is the machine they are going to use. This is the machine they are going to use in order to take out a concrete core from a reinforced concrete member. So this is called a rotary, okay, diamond tool bit cutting. Okay, so here the two things will be there. One thing, one particular rotary diamond tool bit will be there in such a way that you can take only the horizontal member. You can take out the core from the horizontal member only, and some specific equipments will be there in such a way that you can also take out the concrete member vertically also. You can take out horizontally and also you can take. Why I am specifying horizontally, vertically? Because when you want to take out a concrete core from a slab and a, for example, concrete road, okay, you can take out very easily. For example, if you want to take out or test the reinforced concrete member, that is column, how are you going to take out a concrete core from a column? You need a vertical arrangements also. So that will be decided, that is based upon the specification of the equipment. Sometimes that rotary diamond tool bit, okay, will be used both to take out a core in the vertical, also in the horizontal. So and also will be having only horizontal. Okay, so like this arrangements will be there. Okay. Okay, and you can see how exactly the diameter of a concrete core will be. That means once you are going to use this particular equipment to take out a core from that reinforced concrete member, what will be the diameter, what will be the length? Okay, let us see that. So once if you are going to take out the concrete core from a reinforced concrete member, the diameter of the core specimen for the determination of compressive strength in load bearing structural member, that is column, beam, slab, everything, okay, shall be at least 94 mm. That means should be have a minimum diameter of 94 millimeter. It should have a minimum diameter of 94 millimeter. Okay, and usually it will be around 100 millimeter. So usually it will be rounded off to whole number. It will be usually in practice we are going to take it for 100 millimeter. Next, for a concrete with nominal maximum size of aggregate greater than or equal to 1.5 inch or 37.5 mm. That means when you are not going to use aggregates of 20 mm, if you have used 37.5 mm downsize aggregates at that particular instance, okay, you cannot go ahead with this 94 mm diameter core. You need to go ahead with the preferred minimum core diameter shall be 3 times the nominal maximum. That means whatever the diameter of the core you are going to take out from that particular RC member will be 37.5 multiplied by 3. So that will be the diameter you are going to take. Okay. But it should be at least 2 times the nominal. That means if it is not 3 times, a minimum at least 2 times it should possess. So these are all the basic prerequisites that rotary, okay, diamond tool bit it should have. That means I should take out 100 mm for 20 mm downsize, or I should have an arrangement to take out a concrete core. If I am going to use a 37.5 mm aggregate size, means a minimum 37.5 into 2 multiply by. Okay, so that is the diameter I need to take out. So that is the minimum diameter. Is it clear? So this is regarding the diameter of the core you are going to take out from a reinforced concrete member. So like that, let us go with a length or height. The preferred length of a capped specimen, I will explain. So still it is pending. What is meaning of capping? I will tell you. Why it require capping, how to do the capping, I will explain. Okay, so that means the prepare capped specimen means that is the end stage we are going to prepare it for testing. So the capped specimen should have a, okay, the length 1.9 and 2.1 times the diameter of the core. That means it should have 94 multiplied by 1.9. That is the height it should have, or that is the length it should have. Did you get my point? Okay. And or else 94 multiplied by 2.1. So that is the length or height, okay, that concrete core should possess in order to perform the strength or other test on the concrete core. Is it clear? Next, higher length can be trimmed off. That means if you are going to take out the higher length, if it exceeds 2.1 something like that, then you need to, okay, cut that particular concrete specimen, bring down to this particular height. Bring down to 1.9 or 2.1 diameter height. Is it clear? So that is what they have been mentioned. Higher length can be trimmed out for specimen having a low strength. Correction factor need to be applied. That means if the height is more, or the L by D ratio, or based upon the L by D ratio, you need to apply the correction factor, which I am going to showcase you in the next slides. Okay, or which I am going to show you in the next slides. Okay, so this is regarding your diameter and this is regarding your. So finally, if you want to conclude, for whatever the 20 mm downsize aggregates you have been used in the reinforced concrete member, the minimum diameter it should possess 94 millimeter, and the length it should possess, or height it should possess 1.9 into that diameter, or 2.1 into diameter. If there is more than that particular height, we need to cut it and we need to apply the correction factors. Is it clear? This is regarding the length and diameter you need to procure or you need to take out from a reinforced concrete member. Next, after taking out the concrete core, what is the preliminary thing or what is the conditioning you need to do for a concrete core specimen? Did you get my point? After taking out a concrete core specimen, what is the preliminary thing you need to do for a concrete core specimen? That is, after cores have been drilled, okay, wipe off the surface, because I am going to show you the video how exactly the core will be done and how exactly the core will be taken. Here, whatever the equipment have been shown in the previous slide, so that equipment they are going to use for drilling. Okay, apart from or while performing the drilling, okay, or taking out the concrete specimen, they are going to use a water jet. Okay, by providing a water jet between that or in the concrete member, they are going to procure the concrete member. So that's why when you are going to take out a concrete core member, that surface level, okay, it will be having a water. Okay, so that surface level water, drilled water should be wiped off. That surface level should be wiped off. Okay, and allow the surface moisture to evaporate. That whatever the moisture or water content present on the surface of a concrete core, okay, we need to allow that to evaporate. Okay. Next, when surface appears dry, but not greater than 1 hour after drilling, okay, it should not allow to dry it for more than 1 hour. You need to allow maximum is 1 hour to get dry or to evaporate. Place cores in the separate bags or non-absorbent containers and seal to prevent moisture loss. Okay, so now the core has been drilled. Now after drilling the core, wipe off the surface portion on the core, and then you should not allow that, okay, the water content to evaporate more than 1 hour. Okay, lesser, okay, that means once the time reaches to 1 hour, okay, we need to take out the concrete specimen and put it inside the closed containers or in the bags, sealed bags. Why? Because that concrete core should not expose to the atmospheric condition, so that the internal moisture should not evaporate or internal water content should not evaporate. Is it clear? Fine. Next, maintain core at ambient temperature, okay, and protect from exposure to direct sunlight. That's what. If it is exposed to direct sunlight, and automatically the internal water content will be evaporated. Transport the cores as soon as possible to the laboratory. So immediately after taking out the core from the field, okay, you need to transport to the laboratory. That means you need to take out to the laboratory as soon as possible. Cores can be taken out of the bag for a maximum time of 2 hours to permit capping before testing. That means, okay, we need to go ahead with the capping. Okay, that means you need to level the surface of a concrete. In order to level that or in order to apply that capping material, okay, you need to take out that specimen to the laboratory, okay, and the maximum time you can go ahead with 2 hours. Is it clear? Next, if the water is used for grinding or sawing the core ends, complete this operation as soon as possible. That means if you're going to use a water for grinding or taking out a concrete specimen, okay, then complete this operation as soon as possible, but not later than 2 days after drilling. Okay, you should not wait till the 2 days. That means after drilling, okay, you should not wait that concrete core specimen, okay, to take at least for I can say, wait for 2 days, I can say. That's what they've been mentioning. Next, allow the cores to remain in the sealed plastic bags or non-absorbent container for at least 5 days after last being wetted and before testing. That means whatever the concrete core you are being taken, okay, you need to seal it properly. You should not allow that concrete to expose to the external environment. So like that we need to seal it. So this is the conditioning of concrete core specimen. Once if you are going to take out the concrete specimen, these are all the conditioning you need to do for a concrete core specimen. Next, coming to the capping. Now you have been learned what is the length and diameter, how to condition the core. Now you are taken to the laboratory. The core specimen has been taken to the laboratory. Immediately you cannot perform the test. You need to go for capping. What is that capping? Capping means on the top or the bottom surface in which you are going to take out a concrete core will not be even in surface. Whatever the concrete core you are going to procure from the concrete reinforced concrete member will not be even in the surface. It will not be even. It will be having uneven edges. So if you are going to load on that uneven edges, then the load distribution will not be uniform. Whatever the breaking load or whatever the compressive stress you are going to obtain will not be correct. That's why what I am going to do, in order to make the surface level, I must do the capping. That is what the meaning of capping. I am going to apply the material or I am going to do the leveling of the surface, top or the bottom surface, in order to get an even surface. That is what the meaning of capping. The capping may be done both at the top and bottom or at the top or at the bottom, depending upon the evenness of the surface. Is it clear? Next, let us go. The ends of the specimen shall be capped before testing. That's what. The material used for the capping shall be such that, this is the condition, the compressive strength is greater than that of concrete in the core. That means whatever the material you are going to use in the concrete core specimen as a capping material, I will repeat, whatever the capping material you are going to use in order to perform the capping at the ends of a concrete core, that compressive strength of that material should be more than the compressive strength of a concrete. Why? What is going to happen if it is lesser? If it is lesser, before loading itself, it will get cracked. Or else, whatever the loading I am going to perform, it will be not bad. So that's why whatever the capping material you are going to apply as a capping, that particular capping material should possess the compressive strength more than the concrete core. Is it clear? Next, caps shall be made as thin as practicable and shall not flow or fracture before the concrete fails when the specimen is tested. That's what. So you need to apply that capping material as thin as possible, and then shall not flow or fracture before the concrete fails. That means before that loading, okay, or before the concrete core subjecting to the concrete specimen, the capping material whatever have been provided should not get cracked. Next, the capped surface shall be at right angle to the axis of the specimen and shall not depart from the plane by more than 0.05 mm. Okay, so that means like this it will be. So this will be, see, this is what a concrete member. Okay, this will be like this. Okay, so whatever the things, the capping material I am going to provide in order to level the surface, that's what the capping surface shall be at right angle. This is the axis of a member. So it will be right angle to the axis of the specimen and shall not depart from a plane. Okay, and shall not depart from a plane by more than 0.05 mm. It should not get eccentric. Okay, so that is what they have been mentioned. Next, after checking for irregularities, the core shall be placed in water at a temperature. That means after applying, okay, all those things, capping properly, everything after provided, okay, then you need to put that or core specimen in water for a at a temperature of 24 to 30 degrees centigrade for 48 hours. That means take out the concrete core, come immediately to laboratory before 2 hours, okay, apply the capping material. After applying the capping material, you need to allow it to get cured for 48 hours. For 48 hours. Okay. At a temperature of 24 to 30 degrees centigrade. The overall height of the specimen with capping, that means after capping, okay, or before testing. That means once if you are going to cure the specimen, afterwards you are going to test. Before testing, you are going to take the height and the diameter of the core. Okay. So that is regarding the what I can say, the capping. So here I have been showcased what is the material I am going to use in order to perform the capping. So now, earlier we used to follow IS 516-1959 code. Now we have a separate provision or a code or a specification for a sampling, testing and interpreting the results. We have a separate code for sampling, testing and interpretation of results. Okay, so that particular code is IS 516 part 4. IS 516 part 4 2018. We have a separate code. Okay, earlier we used to follow IS 516-1959. Okay, is it clear? Next. Okay, well, the first material they are going to use for capping is cement. Okay, let me see. Test cylinders may be capped with a thin layer of stiff, neat Portland cement paste. After the concrete has ceased settling in the mold, generally for 2 to 4 hours or more after molding. Okay, so you are going to use a neat cement or ordinary Portland cement, okay, which will be used as a capping material. Okay, so those you are going to prepare that cement paste. Those cement paste you are going to apply at the top and the bottom depending upon the evenness of a surface. The cap shall be formed by means of a glass plate not lesser than 6.5 mm thickness or machine metal plate not lesser than 13 mm in thickness. That means in order, okay, we are going to apply those capping material at the center and using this glass plate or machine you are going to press it on the top. Okay, why you are going to press it using a glass plate or a machine? Because those cement paste will be distributed uniformly on the surface of a concrete core specimen. Okay, this is also I am going to show you the video how exactly they are going to do the capping. Okay, so these are all the things you need to see how they are going to perform or conduct this capping of a specimen. Okay, so like that they are going to do. He worked on the cement paste until its low surface rest on the top of the mold. Okay, the cement for capping shall be mixed to a stiff paste for about 2 to 4 hours before it is to be used in order to avoid a tendency of cap to shrink. That means, okay, we need not to, because a cement has a tendency to get shrinkage cracks. Okay, that's why in order to avoid that you need to finish up in the 2 to 4 hours. Addition of paste to the capping plate may be avoided by coating to the plate with a thin coat of oil or grease. Okay, you can do that. Next, also they are going to use one more material called molten sulfur. Okay, they are also going to use a molten sulfur. They are going to use a lime. Is it clear? So there are different capping material they are going to use in order to perform this capping of a material. So next, coming to the curing, okay, the test specimen, that's what, after capping if you are going to perform, so this is the curing procedure which have been provided as per IS 516 part 4, okay. After capping the specimen, okay, that should be stored in a place free from vibration in a moist air, at least 90% relative humidity at a temperature for 24 hours. Okay, from the time of addition of water after dry, because you cannot put it immediately after the capping is been applied inside the for curing for 48 hours. You need to allow that capping material to get what I can say setting. So that's why for 24 hours you need to allow this capping material to get settled with a relative humidity of 90%. That means more humidity. Next, after this period, that means after this 24 hours settling, the specimen shall be marked and removed from the mold, and unless required for test within 24 hours, immediately submerged in. That means if you are going to perform the test immediately within 24 hours, you can perform. Otherwise, you need to, if you are not going to perform any test on that particular day, then you need to immediately immerse it in the fresh water, or you can immerse in the water. So that is what the second thing. Next, the water or solution in which the specimen are submerged shall be renewed every 7 days. Okay, if you are going to perform after 7 days or something like that, you need to, okay, renewal that water. That means it may contain some deleterious material. In order to avoid those things, okay, renew the water. And shall be maintained at a temperature of 27 plus or minus 2 degrees centigrade. The specimen shall not be allowed to become dry at any time until they have been tested. That means the main thing here is the inside core moisture content in the core, or whatever the moisture content is there inside the core, okay, that should not be allowed to get evaporate or dry. That is the main principle behind this particular test. So this is regarding your curing. So next is measurement. Okay, now capping has been done, curing has been done, now you need to test. If you want to test, okay, what is the preliminary thing you need to do? You are going to measure the length and diameter. That is, before testing, measure the length of the capped or ground specimen to the nearest 2 mm and compute this to the length and diameter. That means you are going to measure the length and diameter and calculate the L by D ratio. Determine the average diameter by averaging the two measurements taken at right angles to each other. That means if there is any unevenness, okay, that's why please measure the diameter at the different edges, and average may be taken as the diameter of the specimen. Measured core diameter to the nearest point 2 mm when the difference in core diameter does not exceed 2% of their average. Okay, otherwise measurement, that means you need to abide this condition. You need to abide this condition when you are going to do the measurement. Do not test core if the difference between the smallest and the largest diameter exceeds 5%. That means at one particular core you are going to take the diameter, and another particular location you are going to take the diameter. If those difference exceeds more than 5%, then you cannot perform the core test. You need to go with the recapping of a material. Recap, that means the capping is not uniform. The capping should be done in such a way that, okay, if you take the average, it should be lesser than 2%. The average will be lesser than 2%. Next, test the specimen within 7 days after coring. That means whatever the core you are going to take out from a concrete member in the site, you need to perform after doing the conditioning, capping, taking out length and everything. Okay, within 7 days you need to perform. Next, after subjecting the concrete core specimen to the compressive force, okay, you are going to assess the compressive. That is what calculation of compressive strength of a concrete core. That is, calculate the compressive test of the strength of a specimen using the computed cross-sectional area based upon the average diameter. That means you know the breaking load, you know the diameter. Okay, so based upon the length and diameter and then the breaking load, calculate the compressive strength of a core specimen. So that is as usual you people did it in your basic material testing lab. If the LBD ratio is 1.75 or less, correct the results obtained by multiplying with the correction factor. Okay, I am going to show you, okay, what is the correction factors. If the L by D ratio, that is length to the diameter ratio, is 1.75 or lesser than that, we need to go ahead with the correction factors. The value obtained, that means whatever the compressive strength value obtained might be multiplied with the correction factors is called corrected compressive strength. Okay, so now if you are going to subject this concrete core specimen to the particular load, you are going to get the compressive stress. That whatever the compressive stress you are going to get, multiply that with the correction factor, corresponding correction factor. So that will be the corrected compressive strength. This being equivalent strength of a cylinder having a L by D ratio of 2. That means it will be equal to L by D ratio of 2. So this procedure I am going to teach you now. The equivalent cube strength can be calculated by multiplying the corrected cylinder strength by 5 by 4. That means after getting the corrected compressive strength, the equivalent compressive strength will be calculated, or equivalent cube strength. That means our Indian code used to follow the cubical specimen, because finally whatever the compressive strength if I am going to express or conduct, okay, I need to perform on the cube. Here I have been taken the concrete core which will be in the cylindrical shape. So in order to convert that cylindrical core specimen to the equivalent cube strength, I need to multiply that factor by 5 by 4. Is it clear? So this is the graph which I am going to follow for correction factors. You can see here in the horizontal axis we will be having a H by D. It varies from 1 to 2. 1 to 2. Okay. So based upon the correction factor, ratio, L by D ratio, you can see the correction factors. For example, if the L by D ratio or I to diameter ratio is 2, you can see no correction factor. It is equal to 1. If it is 1, it will be having a different correction factor. It will be, okay, some other thing it will be having, if it is 1.8, if it is 1.6, if it is 1.5, okay, based upon the L by D ratio or H by D ratio, you need to take out the correction factor based upon this particular graph. So this graph is provided in that part for IS 1516 code. And this is the table, you can see, okay, based upon the L by D ratio, this is the correction factor. If it is 1.75, 1.98, if it is 1.5, 0.96, if it is 1.25, 0.93, if it is 1, it is 0. If it is 2, 1. So like that you need to apply the correction factors. So this is a small table which have been showcased for you people in order to teach you or how to interpret the results after performing the test. See, let me take serial number 1, sample number, that means location with which you have procured the core. Now that particular core having a height of 12.3 and a diameter of 6.5. Is it clear? So if this is the specimen, you can see here, as I told, the minimum diameter should be 94, but it is not abiding with the condition. This particular thing we have come across in what particular claim. Okay, so I have taken this particular that example. So now calculate the H by D ratio. You got H by D ratio. Next, to this concrete core specimen, apply the compressive load. Okay, after applying the compressive load, you got a breaking load or failure load of 38.4. Okay, for that 38.4, you know the H and D, and you know this thing, calculate the core compressive strength. Okay, for calculated core compressive strength, you multiply with this correction factor. Okay, this is the correction factor based upon H by D ratio. That is for 1.89, the correction factor is 0.98. So now corrected cylinder compressive strength. How will you calculate corrected cylinder compressive strength? Multiply the corrected compressive strength with a correction factor, that is 11.6 multiplied by 0.985, you will get a 11.43 is the corrected cylinder compressive strength. Did you get my point? Okay, why? Because the L by D ratio is 1.89. If it is 2, need not to apply any correction factor. That means it will be equal to 1 only. Okay, but now it is, since it is a 1.89, so now the correction factor will be 0.98. So hence correction factor multiplied by the core compressive strength will get you 11.43. But we are going to assess the compressive strength in terms of cube. Hence, okay, multiply this corrected cylinder compressive strength by 5 by 4 multiplication factor, you will get 14.28 compressive strength or compressive strength of a cube. So like that you need to interpret the results whatever you have been obtained. So this is the procedure you are going to follow. And one particular sentence will be there in the IS 456, you can see here, as per IS 516-19, this is the earlier code, and IS 456-2000 class 17.4.3, in IS 456 it says, concrete in the member represented by a core test shall be considered acceptable if the average equivalent, if the average equivalent cube strength of a core is equal to 85% of the cube strength of a grade of a concrete specified for the corresponding age. That means, I will repeat the sentence, you will see here, core test shall be considered acceptable if the average of the, here I have showcased one result. Okay, if you are having a number of results, the average of this equivalent cube strength of a course is equal to 85% of the grade. For example, if it is M20, okay, the average of this thing, whatever you are going to calculate, that average should possess 85% of the cube strength, at least a minimum value. That is 0.85 multiplied by 20. So that is the compressive strength, okay, that or the equivalent cube strength should possess. Otherwise, I need to or cannot accept the concrete core specimen. And one more thing, and no individual core has a strength lesser than 75% of the grade. That means whatever the grade of a concrete they have been provided. Okay, so each individual core should not vary more than 75%. So this is the provision given by the IS 456. So if these two conditions abides by the testing results, then we can go ahead with the core sampling. Did you get my point? Okay, so this is regarding your what I can say, the conditioning, curing, okay, procuring of a material, okay, sampling, capping, okay, testing. So this is the procedure you are going to follow. And you can see these are all the factors that affect the strength, size of the stone aggregate. You can see if the ratio of the diameter of the core to maximum size is lesser than 3, reduction in strength is reported. For concrete with 20 mm size aggregate, 50 mm diameter core has been tested to give 10% lower results than with a 10 mm dia cores. So this is the factor that affects. Next, like that, presence of a transverse reinforcement steel. If there is any steel inside the concrete core, what is going to happen? How it will affect the strength of a concrete? See here. It is reported that the presence of transverse steel causes a 5 to 15% reduction in compressive strength. So hence avoid the reinforcement inside the concrete core. Is it clear? The effect of embedded steel is higher on the stronger concrete as it is location move away from the ends. That is towards the middle. That means this particular effect will be more in the case of a middle portion compared to the end. Okay. Next, H/D ratio. You already know what is the effect. Okay. Already discussed about however it is the value should be minimum 0.95 and the maximum is 2. If higher ratio would be cause a reduction. That means if the H/D ratio, more the L/D ratio, okay, lesser will be the compressive strength. If it goes on increases, automatically there will be decrease in compressive strength. Okay. Next, age of a concrete. Okay, so age of a concrete also plays. You can see here. Okay, the average condition, the increase over 28 day strength, 10% after 3 months, 15% after 6 months. Hence, it is not easy to deal with the effect of age and the core strength. So it varies depending upon the age of a concrete. Next, strength. The effect in reducing the core strength appears to be higher in stronger concrete, and reduction has been reported as 15% for 40 megapascal concrete. That means this strength reduction will be more in the case of a high strength concrete. Okay, you can see for a 15% reduction will be there in the case of 40 MPa concrete. However, reduction will be, can say 5 to 50%, that is 50.7 is considered reasonable. Okay, drilling operation, that is also one of the things that will affect the strength of a concrete core. The strength of concrete core is generally less than that of a standard cylinder, partly as a consequence of disturbance due to vibration during drilling operation. Whatever the best precautions are to be taken, because you are going to induce some machine vibration. That means it is going to vibrate and take out. So that machine vibration will induce certain effect on the concrete member. So that also reduces the strength of a concrete core. So these are all the factors that affect the strength of a concrete core. Is it clear? So this is the way you are going to perform or conduct the core test. Okay, and this is the predominantly used semi-destructive testing technique as per Indian code, and this is the test I can say acceptable. And whenever you are going to carry any third party inspection or for the structural adequacy check, for if it may be for a building or it may be for a roads, this particular core testing will is very, very important. Is what I can say, we should be conducted. I can say it is a compulsion. We need to go ahead for this, what I can say, the core testing. Is it clear? So now I am going to show you the small video how exactly this core test they are going to perform. You can see this video. You can see here I have been showcasing the horizontal drilling. You can see here how exactly they are going to drill this. Okay. They are making a point. See, this is the machine. This is the machine they are going to use. Okay. And you can see vertically they are using this particular drill bit, and they are rotating manually in order to take out a concrete core from one of the slab they are taking. From one of the slab they are taking this particular concrete core. You can see that. Okay. So they are drilling. And you can observe that no water jet has been included. That means earlier I used to specify they can use water, okay, and also they are going to take out dry also. Now they are taking a dry, you can see here. And also I think you can see that water already come out. That means already they have been injected a water over there, okay, and they are taking out the concrete specimen. You can see here, completely they have induced water here, they have induced water here, and they are taking out a concrete specimen. You can see over there. Okay, so you can see it is a attachment. Okay, you can see these are 4 screws. They have been attached vertically. Okay, you can take out the concrete core. They are using one equipment or some device to take out the core from that particular slab. You can see over there. You can see this chiseling is chiseling. So this also affects the strength of a concrete. Okay, lightly is taking out. Okay, C is doing light ramming or hammer. Okay, in order to take out, you are making the loose that concrete core. Okay, so that I can easily take out the concrete core. Okay, can see over there. You can see they have been completely taken out the concrete core now. You can see completely they have been taken the concrete core. So this is the concrete core. You can see the edges. See, somewhat it will be uneven. This is what edge uneven. Okay. So like that they are going to perform the concrete core, or they are going to take out the concrete core from this thing. Is it clear? I will show you another video. Okay. So how exactly they are going to do this. So this is the one more video to show you people. Okay. Vertically they are taking. Okay, in earlier video I show you, okay, the concrete core taking from a slab. In this particular video I am making you to see the concrete core taking from a column. Okay, from a the column they are taking a concrete core. You can see over there. You can see over there. Okay, they are fixing this arrangement. So this is what I told. Vertically they can fix it to the column. Okay. So they are doing the fixing arrangements. Next. So now they started with the concrete coring. Okay, vertically. Okay, by inducing a jet of water. Okay, a jet of water will be induced. Okay, and they are going to drill. This is called a rotatory diamond drill bit or tool. Okay, they are going to drill it in order to take out a concrete core specimen. And also you should have a observation that no reinforcement should come out from that concrete core. Because you already know if the reinforcement is there inside the concrete core, automatically the strength will be reduced. So with that, okay, you need to be very cautious regarding the taking out a concrete core. Okay. Next. So like that, okay, they are inducing water jet. Okay. So next, I am going to show you the capping. Okay. How exactly the capping will be done. You can see here. See, this is the video. You can showcase how exactly the capping will be done. You can see over there. This is gypsum capping. They use a gypsum capping. Okay, you can see how exactly they are doing a capping, and whatever the capping material they are using, it should have a strength more than the concrete core. Now they are using a gypsum capping. Okay, the gypsum is there. They are putting a water. Okay, and they are preparing the gypsum paste. Okay, like how we are going to prepare a cement paste, they are preparing a gypsum paste. And later on, they are putting onto the end of this specimen. Okay, a prepared specimen, end of a prepared specimen, and then you can see they are putting this gypsum. Okay, and making it to distribute. Next, see here, this is what we have been told. The glass plate, they are going to press it so that there will be uniform distribution. So there will be uniform distribution of that particular paste, so that you can achieve the uniform distribution. So like that we need to grow it with the capping. This is very important. Why? Because in all the surfaces should have a uniform thickness. If the thickness varies, automatically, okay, you cannot get a accurate result. So like that you need to perform the capping of a material. You can see over there how exactly they have been done the capping. See, they can detach the glass plate. You can see now it is capping has been done. The capping is ready. Now you can perform the testing. So like that we need to go so that you can get a even surface or smooth surface. Like that, I have one more. Okay, you can perform the test. Okay, after that you can perform the test. Like that, we have one more capping. You can see this is one more way to capping. Okay. So they have a device to do the capping so that they can firmly fix this particular cylinder, or they can apply. Okay, they can see they are fixing the cylinder properly. Okay. So like that they are going to perform the capping. See, they have been applying the capping material. See, they are applying the capping material uniformly. Okay, so that they can get an even surface. So like this, I need to perform like that. I need to perform in order to get a what I can say, I need to perform the core testing. Okay. So this is regarding your core testing. So like this, so whatever the video have been shown, so like that they're going to take out the concrete core. Okay. And also have been showcased how they are going to do the capping. So after doing the capping, all those things, okay, they are going to do the testing. So like this, we need to perform the test and undergo this thing. Did you get my point? Hope the core testing or sampling, all those conditions or concepts you have been understood. And the next, on which the very important test I am going to discuss is carbonation test. So now, whatever the concrete core in which you have been taken, okay, as I have mentioned, you can perform the strength test. Apart from that, you can also perform the durability test. the one of the durability test you can perform on the concrete core is carbonation test and pH. So we can determine what is the pH of a concrete and what is the carbonation level of a concrete. Okay, you can identify or we can assess in that particular concrete core. So let us see that. A carbonation test is carried out using a simple phenolphthalein indicator. Okay, this carbonation test, you already know what is the effect of carbonation. I have already been told in the module number 1, that is the carbon dioxide will try to interact with the calcium hydroxide, which is an hydrated compound present inside the concrete, which in terms will lead to the carbonation effect. That means the concrete will try to absorb the carbon dioxide gas. Those carbon dioxide gas will get inside and react with the calcium hydroxide to form a carbonation. So if this carbonation problem arises, okay, then it will decrease the performance of a concrete. So in order to assess this, okay, what is the carbonation level which is there in the concrete? Okay, we are going to perform or conduct the test, okay, like this. Let us see that. So we are going to use a phenolphthalein indicator. Next, phenolphthalein spray is an indicator of pH value and has carbonation as its effect on the pH of a concrete. The change in color indicates the extent. That means whatever the phenolphthalein indicator you are going to put on the concrete specimen, that change in color represents the extent of carbonation that has been undergone by a concrete core specimen. Okay, you can see here. The test is conducted by drilling hole on the concrete surface to different depths. The test is conducted by drilling hole on the concrete surface to different depths. Okay, up to cover, spraying with phenolphthalein indicator and observing the color change. That means take out the core, apply the phenolphthalein indicator and see the color change. How? Let us see. If it is uncarbonated, or I can say no carbonation effect is there on the concrete core, then the color will be pink color or it exhibits pink color. Whatever the phenolphthalein indicator which is pink in color, the same color, okay, replica or which will represent on the concrete core also. Okay. If the same phenolphthalein indicator which have been applied on the concrete core, if the color if color changes, that means no change in color. That means whatever the phenolphthalein indicator have been added on the concrete specimen, if there is no pink color observed, that indicates the carbonation effect has been undergone by the concrete core or carbonation effect is there. So by this color representation, I can know or I can indicate that whether this carbonation effect is there or not. And how to measure the depth of carbonation. The depth of the carbonation will be measured by what is the depth of this particular carbonation that has been under. That means what is the depth of that is change in color or pink color. That means, for example, this is a concrete core. The half portion is pink color and half portion is no change in color. That means a partial carbonation is there. Okay, like that. If it is 1/4 is pink color and a 3/4 is no change in color, that means 3/4 carbonation is there. So like that, the color, based upon the color or the depth of the color, I am going to say the carbonation effect is there. Is it clear? Okay, so like that I am going to perform the carbonation test. Okay, so this is regarding your semi-destructive testing. So I will showcase you how exactly the carbonation will be there. That also video. You can see here. You can see the video over there. You can see here the pink color. This is the specimen. They are going to subject the concrete. You can see here a pink color. Okay, also no change in color. So no change in color indicates it is having carbonation. A pink color, it represents it will be having uncarbonated. You can see clearly. Okay, the pink color. Okay, you can see over there. See, this is the pink color represents uncarbonated. Okay, and the change in color represent the carbonated. So like this I am going to measure the carbonation effect on the concrete core specimen. Is it clear? So This is regarding your semi-destructive testing techniques which have been learned. I have been discussed penetration resistance test, pull out and pull off test, and very important thing today we have discussed core sampling test or core testing, and also have been discussed carbonation test. Okay, but our Indian condition, in our Indian code, we are going to follow majority, or in the majority case we are going to follow with only core testing, because it gives a realistic results. So that's why a core testing is more followed in the Indian code specification. So this completes semi-destructive testing techniques. Thank you.